Hello everyone, and welcome to today's session of Spokane Public Schools Keep Learning Series for Mathematics. Today's lesson's for first grade, but everyone's welcome to join in. My name is Sarah Ball, and I teach first grade at Roosevelt Elementary in Spokane Public Schools, and I'll be your teacher today. But I do have my friend, the rockhopper penguin, joining us today. Let's learn a few facts about rockhoppers. So rockhopper penguins live in South America. South America is one of the 7 continents on the globe, and it's way below where we live. So we live up here in Spokane, Washington, on the continent of North America. If we travel south, we hit South America, and way down at the tip, there are some islands where rockhopper penguins live. Rockhopper penguins are much smaller than which is only about this tall. So much smaller, about half the size or less than half the size of emperor penguins. If you didn't see our previous lesson, you're welcome to view it on KSPS website. It's sometimes helpful to go back and watch the other lessons in our series so you can continue to build your understanding of the mathematics we'll be doing together. So today we're going to do some math flips as a warm-up, and then I'm going to teach you a new math game. You could get a piece of paper and a pencil if you want to write along with us. If you're watching this on YouTube, you can pause the video and make the game board. If you're watching it on TV, you can take some notes and play the game later with a grown-up. So to get started, let's work on our standard. So it says, I can use non-count by ones strategies to add and subtract within 20. So we want to be efficient mathematicians, and counting by ones is sometimes slow and easy to make mistakes. We want to see if we can use some other strategies to help us solve problems, and today's lesson will help you do that. So I'm going to start with some math flips. So what I want you to think about as I flip these cards is, how many do you see? How do you know? And how does side A, or the first side that I show you, help you with side B? And then finally, when I've flipped over all of them, we'll think about, is there anything that you notice about the whole deck that we went through today? So let's get started. Here's your first card. How many do you see? And how do you know? So here there are 7, and 2 more makes 9. Now I'm going to flip to side B. 9 minus 7. So how does knowing this help you solve 9 minus 7? Think about that as we continue through our flips today, and we'll come back to that. So what do you see? How many? And how do you know? So I see 6 and 4, and all together that's 10. And look at the back. 10 minus 4. So again, how does knowing this help you solve this? Try another one. Sorry. How many do you see? 4 plus 3. The total is 7. And 7 minus 4. Try this one. How many do you see? 6 and 3 more is 9. And on the back we have 9 minus 3. And finally we have 5 plus 2. How many? 7. And on the back we have 7 minus 5. So I wonder what you noticed about that deck. I wonder if you noticed the same thing my friend the rockhopper penguin noticed. My friend noticed that if you took this number right here, this was the first one we looked at, we had 7 plus 2, and the total was 9. We saw that number on the back. 9 minus 7. Hey, that was another one of our numbers. So if we took this 9 and we took away those 7, what would we have left? 2. So knowing this addition problem can help us solve the subtraction problem. Let's try it with this one. We have 5 plus 2 was 7. You see here, 7 minus 5. So if we go back to side A, 7 minus 5, what do you think that is? You're right, it's 2. So knowing addition can help us solve subtraction, and we don't have to count by ones. Try this one. 6 plus 3 was 9. Use that to solve 9 minus 3. If you took that 3 away, you would have 6. Thanks for working on that warm-up with me today. You could make these cards at home and try that out with a friend or a grown-up. So now I want to teach you a new math game called Clear the Board. This is another way to practice those non-count by one strategies. And the fun thing about this game is that it's different every time you play. So you don't need a lot to play this game. You need a piece of paper and something to write with. You can use anything around your house that you can write on. Your game board will look like this. So at the top, you'll sketch out 3 empty boxes. And then along the side, you'll write the numbers 1 through 10 with the equal sign next to it. So the point of this game is to choose 3 random numbers, 1 to 6. Some people like to roll a die. If you have a die at home from another math game, you can do that. I just like to choose numbers. You can't repeat the same number. So I'm going to choose for our game today, I'm going to choose a 2 because that's a number between 1 and 6. I'm going to choose a 3 and I'm going to choose a 6. So those are 3 numbers between 1 and 6. Now the point of this game is to be able to clear the board. We want to be able to write an equation using these 3 numbers only that would fit with all of these numbers. Now you can use the number more than once, but you cannot use any number other than these 3. Some people say, well, can I use 0? And the answer is no. You have to use either 2, 3, or 6. You can add or subtract to try to get your numbers. So I'm going to lower my camera down and we're going to play together so that you can see what I'm thinking. And our rock hopper penguin is going to help us with this too. All right, so here you see I have my 2, my 3, and my 6. Those are the numbers that I'm going to use. So I'm wondering, which equation can you build? Oh, what was that? He sees right away. Oh my goodness, you could take a 3 and subtract a 2, and that equals 1. So 1 equals 3 minus 2. Sometimes I look to see if there's any doubles I know. I see right away I could use 2 plus 2 to equal 4, and that clears the 4 off the board. And I also know 3 plus 3 equals 6, and that clears my 6 off the board. I wonder if there is a way to do 6 plus 6. 6 plus 6 is 12. There's not a 12 on the board today, so that one won't work for me. Do you have another idea? Rockhopper Penguin thinks maybe we should try some subtraction. So let's see, what if we take this 6 and we take away 3? The doubles facts help me with that, and that equals 3, so I can clear my 3 off the board by using 6 minus 3. Ooh, and I know 2 plus 3 makes 5, so I'm going to clear my 5 off the board. Ooh, how can I get a 2? Let's see. If I take away 6 minus 3, that didn't work. 6 minus 2 equals 4. Oof, that's tricky. What if I add 2 plus 3? That makes 5. So if I have a 5, how can I get back down to a 2? Oh, I could take that 3 out. So I could say 3 plus 2, that equals 5. Now remember, I can't use 0. It would be really easy to say 2 plus 0 equals 2. But I have to try to get to that 2 another way. So I'm going to say, okay, 3 plus 2, that's 5. And I put these parentheses around it. Don't worry about that if you don't want to do that. 2 plus 3 equals 5. And then I'm going to subtract out that 3. And we know 5 minus 3 equals 2. So I just cleared this whole side is clear. Now I have to try to build some higher numbers. Let's see, how could I build a 7? I know 5 plus 2 makes 7. That's a known fact for me. So how could I get a 5 out of here? I could use that 3 plus 2 again. 3 plus 2 is 5. And then 2 more gets 7 because I can use 2 more than one time. What's that, Copper Penguin? You saw another one where you can use 3 add-ins? thinks that you can do 10 by making 6 plus 4. And since there's not a 4 here, he said use 2 and 2. So I can go 10 equals 6 plus 2 plus 2. Oh, I'm so close to clearing the board. I wonder if I could make a 9. Let's see, what is 6 plus 3? I knew 6 plus 4 was 10, so 6 plus 3 is just 1 less than that. 6 plus 3 is 9, clears the board, and 6 plus 2 must be 8. Look at that. We were able to clear the whole board with help from our rockhopper penguin today. Thank you so much. So this is a great way to practice our strategies and how we can get to numbers in lots of different ways. You can extend this game in many ways. You could play with more than just 1 through 10. You could go up to 20 even if you want to on your board and choose bigger numbers up here at the top. You could play this game by including multiplication and division if you're playing with a friend or a grown-up, or maybe you want to try out some of your multiplication and division. So there's lots of ways you could play clear the board, and all you need is something to write with and a piece of paper. So thanks for joining me today. I enjoy doing mathematics with you. And if you want more activities, feel free to go to the Spokane Public Schools Learn at Home website. I look forward to seeing you again at our next lesson on KSPS. Don't forget to play your game. You can do it lots of times and it will turn out different every time. Bye.
Hi, first grade. Mrs. Yahara here with Spokane Public Schools, ready for another math moment. Today we're going to be thinking about how the equal sign works. So we're understanding the meaning of the equal sign. And in our work today, if you would like to have paper and pencil to help you in solving some of the expressions that are on the board, or just to kind of help take notes and think about your thinking, go ahead and grab that. If not, that's okay. You don't need it. You can just join along with us and maybe do some of this math mentally. So the expression that we're going to be looking at is this. 5 plus 2 is the same as 6 plus 1. So when you think about this, we might not be used to even seeing math written like this, but if we think about math as a form of communication, kind of gives us a different purpose for writing something like this. So 5 plus 2 is the same as 6 plus 1. Is that true or false? So take a moment, maybe talk about it with someone next to you. Is 5 plus 2 the same as 6 plus 1? Now, even if you have never written a math problem like this, does that mean that you can't write a math problem like this? I don't know. Let's take a look. All right. So when I look at a math problem like this, I have to think about this equal sign that's in the middle. And a lot of times when we use an equal sign in math, it means we write the equation and then we put like 1 plus 1 equals 2. But the equal sign actually has a bigger meaning than that. So 5 plus 2 is the same as 6 plus 1. So anything that we have our equal sign, anything that happens on this side, if we have an equal sign, has to have the same value as on this side. So let's take a peek. If I know 5 plus 2, what is 5 plus 2? 7. What is 6 plus 1? 7. If I bring my equal sign down, is 7 the same as 7? It is. So is this true or false? This equation or expression is true. 5 plus 2 is the same as 6 plus 1. It doesn't look the same. This side makes 7, and this side equals 7. It doesn't look the same on both sides, but they both have the same value. All right, let's try another one. So again, we're going to do true or false. Are you ready? Oops. Four plus 3 is the same as 5 plus 3. So that would mean, if I have my equal sign, this expression has the same value, creates the same value as this expression. Is that true? So let's take a peek. Talk to your neighbor next to you. Talk it out. And if you think you know the answer, tell them why you think that's the right answer. What's your explanation for that? So 4 plus 3, we know that makes 7. 5 plus 3, what does that make? That one makes 8. So are they the same value? No, they're not. And that's the sign that we use in math, that mathematicians use to show that these are not balanced. These are not of the same value. They're not equal. 7 and 8 are not equal. So these are kind of fun things to do, to have our grown-ups even do with us, to create expressions like this. Sometimes one side could be addition, one side could even be subtraction. To kind of create expressions like this that we have to solve. Are they true or false? So see if your friends or family or someone in your house could maybe create a couple of these for you to try to solve, to find out if they're true or false. And maybe, just maybe, you could even create a couple to share with family to find out if you can catch them, if it's true or false. All right, so today we were working on understanding the meaning of the equal sign, and I'm looking forward to the next time we're together for some math moments.